So a lot of what we've heard in this session has been about learning analytics and or personalization, how to take learning analytics and personalize courses from it, for example. And what I'm going to talk to you about is what Zoomi, a company that I work at, I'm the head of advanced research, co-founder of Zoomi, is working on. And that is to take a behavior-based approach to trying to do learning analytics. So we delve very specifically into the learning experience, figure out what learners are doing, when they're doing, when they fast forward, when they rewind and lecture videos, and use that to create more fine granular personalization. All right, so let me start off with an example. If you guys take 20 seconds and read this question. If it's too small, let me read it for you. Question 1. Which of the following is an example of confidential information? Is it A, a list of upcoming opportunities a new joiner knows his former employer is pursuing? Is it B, a client's product development roadmap from its annual report posted on LinkedIn? C, a list of competitors' key clients taken from its website? Or D, a competitor's quarterly revenue forecast as reported by industry analysts? It's A, right? It's pretty easy. This is actually a question taken from a course hosted by one of our clients. So my question to you is, do you actually need a course to know how to answer that question? Probably not. Right? I mean, it's going to be biased towards the fact that everybody is going to probably get it right, unless they're just guessing randomly as they go through. And actually, lots of corporate training content is like this. The questions are very easy, and a lot of times people will just skim through and try to get to the answer to the questions. But that's not to say that there's not useful content. Companies spend up to billions of dollars a year, believe it or not, on corporate training. So there's got to be something worthwhile in the content. So rather than focusing on question responses for corporate content, learning analytics, I believe, should indicate whether learners are progressing as expected, diagnose points where maybe content's not having its desired effects, give predictions of learning outcomes, but not learning outcome like whether someone gets a question correct or incorrect, a learning outcome such as a change in operational performance. When they go back to their workplace, are they doing better? Are they doing their job better than they were before the course? Now, of course, there's a lot of confounding factors there, but if we use some mixed effects modeling, we can probably eliminate those and try to isolate the effect of a specific course. Or knowledge transfer. Maybe knowledge transfer not measured by the questions at the end of the course, but measured by some assessment of their knowledge when they go back to the workplace. It should also be able to give recommendations on how to improve learning efficacy, and learning analytics should lead to automated personalization. This is a very simplistic, high-level feedback loop, but I think anyone who's trying to deploy personalization follows this to an extent. Capture data about students, could be at a course level, whether they're completing or not completing, could be down to the video level, their clickstream measurements. Model that, throw analytics to an instructor from that model, and use that model to in turn drive a path switching algorithm that's going to determine whether they stay on the current path or switch, and then close the feedback loop and capture the data again, see whether it was effective or not. So what kind of data do we typically have access to? And this is across all settings, not just in corporate training. There's at least 4 groups that I can think of. One is clickstream measurements, learners watching video lectures, when they play, when they skip, when they pause, skip back. Social interactions, when people are talking on discussion forums or within the enterprise social network at their company. Jive, Yammer, whatever it may be. There's question responses, of course. That's definitely valuable data. It can be valuable. Not all questions are useless. I'm not saying that. How learning is normally assessed, especially in higher ed settings. And the 4th one, content and user words. Peter was talking before about how do we actually generate the process of a course being created or a textbook being created, and that has to do with modeling what topics are going to appear where, what's the progression of topics. So that's also data that we can use as well. So then, these data sources are great and they're abundant, right? I mean, of course, you may be able to capture, say, even up to 1,000 measurements probably for one student on a couple hour-long course every time they click and so forth. But then you have to be able to relate it to learning outcomes. So you need to do a lot of pre-processing, a lot of data mining. Data is very noisy, especially click measurements, unintended interactions, and so forth. So that's what Zoomi's all about. We're AI for learning, that's the tagline, but it's really AI for learning from behaviors. We have a player, it's a course delivery platform. Looks something like this, captures this fine granular type of data about users. We have a dashboard that provides this fine granular learning and content analytics. And the engine, which drives the player in the dashboard, the different algorithms that do that. And we're servicing corporate training, professional certification. Those are our biggest clients today. Also, some providers, private tutoring, especially in Asia, and also higher education. So a lot of different scenarios. So now I'd like to give you a couple examples, rather than delving into any specific methodology. I'd like to give you a couple examples of different methodologies that we've developed to work with each of these different sources of data. The first one is what we call behavioral motifs. Motifs are like the learner's DNA. Think of them that way. They're significantly recurring subsequences of behavior. We extract these through sequential pattern mining applied to a learner's clickstream data. Right, so if I come up with some character set, some alphabet of plays, pauses, skip forwards, skip backs, and the lengths and durations associated with them, I can apply a mixture model to that, a combination of this position-specific motif model versus a background model that's position independent, just to reduce the effect of any particular character occurring. We've come up with motifs that are pretty intuitive with how you would think that someone would go through a course. Reflecting, like their record keeping. Pausing for a long time, playing, pausing for a long time. Reviewing, which is actually skipping back instead of just pausing. You're revising over the same kind of material. Skimming, which is the counterpart of reviewing, where you're playing a little bit and you think you know it, so you skip over a lot of the material. That's very common in corporate training, we can all agree. And speeding, when you're changing the playback rate, especially if there's a really boring lecturer or someone who speaks really fast, you want to slow their rate down and so forth. What's interesting is that these tend to have surprising associations with outcomes. They will be content dependent. A reviewing motif on some content may indicate a very positive outcome, whereas on another piece of content it may indicate a very negative outcome. And same thing with learner, it's also learner dependent, so there's a lot of different factors here at play. Here's two examples. These are from one of our clients and some data that we've analyzed. So one motif example, performing the sequential skimming actions of reading a slide for less than 10 seconds, skipping forward more than 14 slides, and then reading a slide again for a long time, actually increases their QFPT score, quality final process training score. It's something assigned to them after they go back to the workplace by this specific client, corresponding to an increase of 2.47% with a significant p-value. On the other hand, on a different set of content, we had another skimming motif that corresponded to a drop in QFPT outcomes of negative 7.9%. So right away, this is going to give you content analytics, right, for an instructor. You know what's happening in here and what's happening in here. What's happening in here may not be very important, right, because they were still able to actually get better scores afterwards when they didn't look at it. Whereas what's happening in here might be very important, and you should encourage learners to actually focus on that and look at that. So then you can take this type of analytics and apply it to prediction. We heard a lot of talks today about performance prediction, grade prediction. How about outcome prediction? Can behaviors be used for early detection of learning outcomes? We need to do a lot of feature engineering. I won't bore you with the details of that. But if we simulate an algorithm or evaluate it day by day, where we take the data that comes to us in day 1 of the course, day 2 of the course, day 3 of the course, and try to predict off of that information, here's an example of in one of our courses how the predictions get better and better over time. So by say day 10 or so, we're already getting about 80% AUC. Actually, the newer graph we were up to closer to 90% AUC. One of our courses, that's a really good place to be at. So if by day 10 I could really tell you from someone's behaviors By the way, this setting right here is entirely behavioral driven. There's actually no assessments at all. The instructor just at the end of the course assigns either pass or fail to the person.
Yeah, just wondering your measurement of outcome, is it a progression or just performance?
It's right at the end of the course. That's what's really interesting about it. We don't really know. The client just tells us at the end, these people passed, these people failed.
Okay, because you could think that those people who have this particular pattern are just already good.
Yeah.
Right?
Correlation and causation.
Right. Either way, though, if you could predict it in
Right,
advance.
no, yeah, sure. But I mean, maybe what they're skipping is important, but they already know it.
Yeah. Yeah, but if you do it, this is one example where you're doing, I see this one now. If they already know it, then, okay, they're going to skip over it. But in these examples, actually, I'm looking for a change in their quality score before and after. But you're right, in this setting, it could very well be that they already know it.
Okay.
Therefore, good point, thank you. Now let's talk about social data. How do we optimize social learning networks? Can they be made more efficient? So there's a couple of key modeling components we define. It involves extracting the topics that people are discussing, estimating the parameters, whether someone's seeking or someone's disseminating on a topic-specific basis, and then running some network optimization that tries to maximize some notion of utility, right? How much are people actually benefiting from the current observed structure? That utility measure can also be tied in with someone's outcomes as well, right? If it was working for them, then it would be higher utility. And what we found is that optimized networks can have up to 30% improvements in this measure of utility without actually sacrificing any local utilities, because there's always a global versus local trade-off. Individual people may suffer at the expense of the average going up a lot. But what we find is that there's a lot of room for improvement by instantiating new connections and recommending new connections between people. This is all in InfoComm 2016 as well. Then we took that a step further. Can we actually run prediction in social learning network? Can you predict link formation in advance? Link prediction in social networks is actually a pretty well-studied problem. Trying to predict whether two people are going to become friends later, say on Facebook, or follow each other on Twitter. In a social learning network, it poses some new challenges because people are going to talk not necessarily just because they have topics in common, but because they have a difference in abilities, right? That's also going to be a key driver here. In fact, in a social learning network, the predictions you look for, people will tend to have very different sets of skills rather than very similar sets of interests, right? The person who's an expert and the person who's a novice are going to be quite different. So we wanted to know, can we do this prediction in advance? Get some pretty good AUC scores, but I think even more important than that is, what are the analytics that are provided as a result of this? If you run a neural network, can you actually take that and use it? And I think that, you're not going to show an instructor a heat map of, the hidden state and the forgetting gate. But if you look at this forgetting gate in this neural network, it's a time series recurrent neural network, that's a forgetting gate. Over time, you see some of the neurons become more and less interesting or useful over time. So it's interesting for someone to be able to see how the different sources of data are going to change in their predictability. Content topic analysis is another one, working with the final form of data, just the content data itself. Can we determine how to improve a course, say, just by analyzing its topic progression? Forget about how people interact with the content. A lot of times, actually, when we work with clients, they're not going to have that data up front. They're not going to be able to tell you how learners are behaving, because they're not collecting that data. But there's nothing stopping you from, say, taking all their content and running huge topic analysis on it and just providing them with a heat map, say where different topics are displayed. We run some generative NLP model. So I could see for each of these topics what some of the keywords are, and I could tell, say, topic 8. Right, topic 8 is covered very lightly in different parts, and also heavily in other parts, but it's also not assessed ever. Right? So you can compare that with the quizzes. It never really appears in any of those quizzes there. So is that content important? Should you take out the focus on topic 8, or should you add some assessment covering topic 8? even if assessments are useless. That's a joke. Then the last step of this, and I'll stop in 1 second, is how do we turn this into individualization? So we have this concept of this no-touch individualization system, NTI. No-touch means nobody has to do anything to set it up, right? It just works. You don't have to provide tags in advance. You don't have to provide any sort of pathing in advance, which is usually necessary. And we do that by using different machine learning methods for the tagging, user modeling, and the path switching processes. Tagging through content analysis, user modeling through these behavioral motifs, and path switching through reinforcement learning methods. Right? Figure out what's working well. It can be initialized by content itself too. And the whole premise of this is that we can divide content files into these small little segments. Treat a PDF as its paragraphs that are within it. Treat a video as 15-second segments. Serve up the important segments when someone needs remediation of it. We've seen some nice results initially. The red is the linear case, the one-size-fits-all version. The green is module level individualization, so if a course is a sequence of units or modules, it's applying this where you then show a previous full module rather than down to the segment level of individualization. And the final level is the segment level. We measure productivity, roughly speaking, as the points that they're gaining in this course per unit time that they're spending on it. That's some measure of efficiency and productivity. And generally, you see that chapter by chapter, the segment level is able to do better than the module level, which in turn was better than linear. Here's some references to help you guys fall asleep if you'd like. I just gave you an overview of a lot of what's in these papers, and with that, there's 1 minute left, so I'm glad to take questions before the session's over.